Hi guys, today we're going to learn about limits. We know that if f of x becomes arbitrarily close to a single number L as x approaches c from either side, the limit of f of x as x approaches c is L. This is going to be written as follows. The limit of x that approaches to c of f of x is equal to L. Now, one-sided limits, please note that this is one-sided limits, can be expressed with the following notation. The limit of x that approaches c from the right of f of x is going to be equal to L. Please note that the c has a little hat here, which is telling you that this limit is the right limit. Okay? So this limit is stating that the limit of f of x as x approaches to c from the right is L. On this one, you can see that the little hat changes. The limit of x that approaches to c from the left of f of x is equal to L. This limit states that the limit of f of x as x approaches c from the left is going to be L. So let's look at this example. So if we have that f of x is going to be equal to x cubed minus 1 divided by x minus y minus 1, they ask you to find the limit when x approaches to 1 of f of x. So what's the meaning of this expression? Well, what they are asking you to do is compute the limit when x approaches to 1 of what? Of this expression that I have over here. Okay? So what's the deal with that one? What you know from here is what? What do you know about that? Well, obviously, if I replace my x's with 1s, this becomes a 0 over 0, which is a problem. So you don't want that. So we need to factor. Can we factor this situation? And you're like, oh yeah, because this is the difference of cubes. Okay, we can use the difference of cubes. So you know that it's going to be the limit when x approaches to 1 of what? It's going to be x minus 1 times x squared, okay, plus x plus 1 and everything divided by x minus 1. Now you can see that we can cancel stuff and things. In this situation, what you have is that we can cancel this situation. Okay, so following this idea, I have that limit is going to be equal to the limit when x approaches to 1 of the expression x squared plus x plus 1. Oh, plus 1 plus x, it's the same. Okay, so this is going to be equal to what? What? Okay, so it's going to be equal to, well, I'm going to basically evaluate my expression when x equals 1. So you have 1 squared plus 1 plus 1. So this is going to be equal to 3. Okay, and that's your answer for this limit. Okay, now let's look at more examples over here. Sometimes we can do this graphically, and you are going to see common types of behavior that it's associated with the non-existence of a limit. In the first situation, we have that f of x approaches a different number from the right side of c than it approaches from the left side. Okay, so let's look at this example. I'm giving you the graph. First, let's read the expression. G of x is equal to the absolute value of x minus 2 divided by x minus 2. They ask you to find the limit of the situation. The cool thing here is that you have the graph. Okay, so obviously something is happening here. Okay, at 2. I know that the problem is at 2. Okay, so I know that here I'm going to have an open circle and also over here an open circle. I'm assuming that my copier didn't went all the way for the line, so let's correct that. So your equation looks like this, right? When we graph that situation. Okay, so what do you have? We have that the limit when x approaches to 2 from the left of g of x is going to be negative 1. Now, when you evaluate the limit of x that approaches to 2 from the right, you have that limit is going to be 1. Since the limits are not the same, because you know that 1 and negative 1 are not the same, we know that this one does not exist. Okay, and you can conclude that because, okay, because what do you know? the limit of x that approaches to 2 from the left of g of x is going to be equal to -1, and the limit of x that approaches to 2 from the right of g of x in this situation is equal to 1. Since they are not equal, do not exist. Okay? Another important case that you have over here is when f of x increases or decreases without a bound, okay, as x approaches to c. What is without a bound? Okay, like very, very fast, or pretty much infinitely, okay, infinitely. Okay, so in this situation, you have a well-known function, the limit of x that approaches to 0 of the function 1 over x squared. Okay, so here you have the graph of 1 over x squared as a function. So what do you have here? The problem that we have at 0 is that at 0 from the left, it goes, you're going to tell me, oh, it goes to positive infinity. True. And this one, it goes to positive infinity. So this one, without a bound, is it increases like without a maximum, okay? Or, yeah, without a bound, okay? So this one is infinity. Okay, so why it's infinity? Because it's going to positive infinity in both sides. Okay, so in this situation you might tell me, oh, okay, so the limit when x approaches to 0 from the left, 1 over x squared, is going to be infinity, and the limit of x that approaches to 0 from the right of 1 over x squared is going to be infinity. Are they the same? Technically, yes, they are. Okay. For the third case, what you have is that f of x oscillates between two fixed values as x approaches to c. In this situation, we have that the limit of x that approaches to 0 of sine of 1 over x. You have the function over here, and it's very difficult to see what's going on at x equals 0 because you have to look over here, and it's very difficult to see what's going on. To kind of like see what's going on, what I'm going to do is I'm going to set the function f of x to be equal to sine of 1 over x, and I'm going to evaluate this function in the values that we have over here. Okay, so let's go to your calculator. Okay, so what you're going to do here is you're going to sine, okay, and you want sine of 1 over, and you want negative 0.1. That's the first one that I have over here. Okay, so you have that value is going to be 0.544. Following the same idea, you have that you copy this one, and what I'm going to do is I'm going to add a 0 there. So you have that it's positive 0.56, and then you have the next one over here where you copy this one and you are going to add another 0 because that's what's going on here, and you have that it's negative 0.826. Now you're going to tell me, hey, two things. First thing, my calculator is in radians. Second thing, why I'm doing this? Because you are looking at numbers that are pretty close to 0. Okay, so I'm going to skip the 0 because I know that if I plug 0, this is going to be undefined, which is going to be a problem. That's why I'm looking for the limit. Okay, after that, you evaluate this at positive 0.001, okay, which gives you the same value but positive. Okay, and then this one is going to be the same value but negative, okay, which is negative 0.506, and this one is going to be also the same value but negative, negative 0.544. Okay, so with the trend that we have here, since the sign is changing and these two are not equal, we can conclude that this limit does not exist. Okay, so this limit does not exist. Why it does not exist? Because these two are not even close. Okay, so they are not going to meet at 0. For the last example, you have to search for the limit when x approaches to 0 of sine of 5x divided by x. What we're going to do here is pretty similar to the previous example. So I have that f of x is going to be equal to sine of 5x divided by x. So what I'm going to do here is I'm going to evaluate this function with these values. Why? Because I want the limit when x approaches to 0, therefore these values are pretty close to 0. Okay, so again, I need my calculator. Okay, so I have my calculator over here. So you have that it's going to be sine of what? 5 times, and you know that it's going to be negative 0.1, and that one is going to be everything divided by negative 0.1, and that one will give you that it's going to be positive 4.794. Okay, in the same way, you copy this value, and then I add a 0 here, and I add a 0 over here, and then you see that it's 4.997. The next one you have that it's 4.999. This one is going to be 4.999. When you evaluate it in the calculator, this one is going to be 4.997. And last but not least, you have that this one is going to be exactly the same as this one. Okay, so try it in your calculator. Now, what can you conclude here? When I plug this in the calculator, okay, if you try, what happens? Try it. Okay, I'm pretty sure you know what's going to happen. Okay, the calculator is undefined, so when you evaluate this, does not exist, but you can see a trend. What's the difference between the previous example and this one? These two are the same. So my conclusion here is going to be that this limit goes to 5. Why? Because these two, they share the same sign, and technically they are going to tend to 5. Okay, so that's how you can conclude here. And that's it for today. I hope that you find this video helpful. Bye.